You know, there's this invisible war being fought right now for the future of all of our data. It's this massive race to build a new kind of digital shield before a totally new kind of weapon shows up. And that's what we're going to break down today, the coming age of post-quantum cryptography. So let's kick things off with a kind of a weird question. Is your data safe from computers that don't even exist yet? I know, it sounds like something straight out of science fiction, right? But the kind of scary answer is maybe not. And that's exactly what we're going to unpack here.
Okay, so before we dive into the threat, we first have to understand the shield. Let's take a look at what's protecting our digital lives at this very moment.
Think about it. Every single time you send a message or buy something online, or even just log into an account, you're being protected by this thing called public key cryptography. You can't see it, but it's there, like an invisible shield that scrambles all your information, making it total gibberish to anyone who doesn't have the right key.
And this whole shield, it's basically built on a handful of really hard math problems. I'm talking problems so difficult that even the fastest supercomputers on the planet today would need like billions of years to crack them. That right there, that's the foundation of our entire digital world.
But what if a new kind of computer came along, one that just didn't play by the same rules? Well, that brings us to the quantum threat.
So meet the quantum computer. And this isn't just a faster version of your laptop, it's a completely different beast. It thinks in a fundamentally different way. And it just so happens to be an absolute genius at solving the exact kind of hard math problems our current digital shield relies on. For a quantum computer, our unbreakable problems, well, they become almost trivial.
Yeah, experts have actually given this future moment a name, Q-Day. Think of it as the day a quantum computer finally becomes powerful enough to just shatter our cryptographic shield. In an instant, all of our current protections could become totally obsolete. And this leads to a really chilling strategy. You see, adversaries know Q-Day is coming. So right now, as we speak, they're stealing and storing massive amounts of our encrypted data. They call it harvest now, decrypt later. They can't read any of it today, of course, but they're basically hoarding it, betting they can unlock everything the moment Q-Day arrives.
So the big question is, when do we actually need to worry? Well, there's this simple formula called Moscas theorem that helps us figure it out. Let's say it takes you X years to upgrade all your security, and you need your data to stay safe for Y years. You're in big trouble if X plus Y is greater than Z, where Z is the time we have until a powerful quantum computer shows up. And think about it. For things like government secrets or medical records that have to be secure for, say, 50 years, the deadline to start migrating was basically yesterday.
Okay, but don't panic. Seriously, the world's best cryptographers aren't just sitting around waiting for Q-Day. They are already hard at work, right now, building a brand new quantum-proof shield.
And this new shield has a name, Post-Quantum Cryptography, or PQC for short. It's a whole new generation of encryption, and it's built on completely different math problems, ones that are believed to be hard for both our classical computers and those future quantum computers to solve.
Now, the strategy here is really smart. They're not putting all their eggs in one basket. Instead, researchers are developing this whole toolkit of different PQC approaches. You've got lattice-based, hash-based, code-based. Each one is built on a totally distinct area of math. It creates a diversified defense, so if a weakness is ever found in one, the others will still hold strong.
But this new security does come with some trade-offs. Just look at this comparison. A standard key that we use today is tiny, just 32 bytes. But one of the new government-standardized post-quantum algorithms, something called Crystal's Kyber, needs a public key that's over 40 times larger. That's a huge difference.
So here's the crucial point. Getting quantum safety means we often need bigger keys, and frankly, a whole new way of thinking about security. This isn't a simple patch. It requires a fundamental redesign of many of the systems we rely on every single day.
And because these PQC algorithms are still pretty new, engineers are using this really clever safety net called hybrid encryption. What they do is protect data with both a new post-quantum algorithm and a trusted classical one we've used for years. That way, even if some unexpected flaw is found in the new PQC algorithm down the road, our data is still protected by that old battle-tested shield. It's like having a belt and suspenders.
Now, I know this might all sound like it's way off in the future, but the transition is already happening. This is not science fiction anymore. Your quantum-safe future is literally being built right now.
I mean, the academic work started years ago, but just look at the acceleration lately. In August 2024, the US government officially published the first set of PQC standards for everyone to use. And just a few months before that, Apple announced it was already rolling this stuff out to iMessage. The race is definitely on.
In fact, there's a good chance you're already using PQC without even realizing it. Secure messaging apps like Signal and iMessage are leading the charge, and Google is testing these same protections in Chrome and its other services. This is happening right now, on the phone in your pocket.
And here's the proof right here. This is the screenshot showing a live, post-quantum secure connection happening in a web browser. The invisible shield is already being upgraded all across the internet, getting us ready for a threat that's still just on the horizon.
So here's the big takeaway. The invisible shield protecting your entire digital life is being reforged as we speak. It's one of the most significant technological upgrades in history, and it's happening almost completely behind the scenes. It really makes you wonder, what other hidden tech that we rely on every day is going to have to evolve for the quantum age?